Crazy Hat Chemist. So today we're doing another video in atomic structure and electron configuration. So let's get moving. Bam! So the d-type orbital for the d-type in diffuse type atomic orbitals. Okay? The d-type orbitals are multi-lobe. They get very complex here on from this point forward. Okay? When L equals 2, it's a d-type orbital. When L equals 2, that lets you know that there are two planar nodes. Remember the x, y, and z planes. We're talking about a three-dimensional object that is an atom here. Okay, the m sub L values are 2L plus 1. That gives me the L value of 2. I'm going to plug that right into that 2L plus 1 equation, and I get 5 atomic orbitals. Okay, the 5 atomic orbitals are all the plus or minus all the L values at the time. So that's a 0, that's a 1, and that's a 2 of that same principal quantum number. This is when we start n equals 3. n equals 3, we have L values of 0, 1, and 2. Okay? And then it's like a number line, but it's not. But you can get the same numbers using a number line with the middle number being a 0. To the right of that would be 1 and 2. To the left of the 0 would be a -1 and a -2. Okay? So, plus or minus all the L values. You have 5 atomic orbitals. Now, with the S-type orbitals, we had 1 orbital. With the P-type orbitals, we had 3 orbitals. With the D-type orbitals, we have 5. Okay, what is the next number? You're going to think about that for the F-type. Okay, all right. So the 5 individual orbitals are having these labelings. Instead of the PX, PY, PZ, it's a multi-label labeling here. Okay, so take a look at those, and those correspond to the shapes. And these are the shapes. This is a diagrammatic view of those shapes, and these are just like in the S-type orbital where we had an electron density map. Okay, these shapes are experimentally proven with an electron density map and mathematically calculated to get these shapes. So the two correspond, and that's the beautiful thing about Schrodinger's equation using his calculus-based math. Okay, so you should see those 5 different types of orbitals with those 5 different shapes. Remember, L is 2, that means it's a d-type orbital. L is 2, that means there are 2 planar nodes. I've just labeled 2 sets of the planar nodes. Remember that each one of these orbital sets has 2 planar nodes in them. Okay, hopefully you can see that. Now, since the m sub L values, there are 5 orbitals. Here are the m sub L values corresponding to their orbital boxes. So this is going to be coming up with an orbital box diagram. I have 5 boxes. The middle box is a 0. To the right of that, 1 and 2. To the left of the 0, -1, -2. Those are the m sub L values of those orbital box labeling. Okay, now here are all the d-type orbitals. I'm going to do a superimposition of all 3 of these, and I get right here in the center right here. Okay, now remember, this is a superimposition of all 3. This is remembering back to ogres and onions, and these are the layers of the onions all together there with the orbitals. Okay, so each set of orbitals is a whole entire orbital set for these 5 d-type orbitals. Okay, that's another Crazy Hat video by the Crazy Hat Chemist, and I got a great here hat for you. I don't know what day today is, but maybe it's a day for Dr. Seuss, and I think every day is for Dr. Seuss. Okay, if you like that video, give me a thumbs up. Please subscribe to my YouTube channel. I would greatly appreciate that, and I will see you next time for more cool chemistry videos. Bye now.